Hi everyone, welcome to our presentation. I'm Leland, one of the presenters of Group 9. Today I'm going to talk to you about the software architecture of Yummy. I'm going to focus on the three deliverables, which are the conceptual architecture, the concrete architecture, and our proposals for enhancement for the project. First, I'm going to give you a quick introduction to Yummy. Yummy is a fully distributed communication platform by using OpenDHT to find contact IP addresses, which respects the freedom and privacy of its users. It's a free and open source software, and you can reach your friends directly in peer-to-peer. It works as an instant messenger and is compatible with many operating systems. The second part of the presentation is our recovery of the conceptual architecture based on reading the documentations. It contains the architecture style, the derivation process, the derived conceptual architecture, the sequence diagram, and use cases. Let's take a look at the derivation process of the conceptual architecture. First, we searched for some Yummy-related materials. Then we analyzed Yummy by delving the MVC architecture. Then we carried out a deeper understanding from model, view, and controller, and the underlying distributed network architecture from the source code of Yummy from the framework. This is a diagram of the MVC architecture. It contains three layers. The model layer responsible for the underlying communication, the view layer responsible for the user interface, and the controller layer responsible for the communication between the model and the view. This diagram clearly shows the interactions among these layers. As you can see from the graph on the right, Yummy always attempts to use the most direct available link between peers by avoiding any relays between them. This is our derived conceptual architecture. As discussed earlier, there are four major layers in the system of Yummy: view, controller, model, and distributed network. One thing we wish that we knew ahead of time was that the core of Yummy is not the controller, but the model, which we'll discuss later in the concrete architecture part. The view layer defines the user interface of Yummy, and the clients of each platform are implemented based on this interface. The model layer is the core of Yummy. It runs as a daemon and handles all the processing. The view layer cannot directly call the model layer interface. The communication between them must transmit through the controller layer. Yummy uses dbus as the controller between the view and the model. dbus is a message-oriented middleware. The main difference between Yummy and the traditional communication software is that Yummy is a communication software based on a distributed network. The realization of all Yummy communication, message, and other functions based on the distributed network, except for some specific cases. Yummy was built on two distinct distributed networks. First one is OpenDHT network, which provides connectivity establishment and message distribution. The second one is Yummy NS blockchain, which provides name registration. The sequence diagram is pretty self-evident. You can see clearly how the system works and how the components interact with each other when the user attempts to do something with their account. The third part of the presentation is about the concrete architecture. We're going to talk about the derivation process, concrete architecture, subsystem analysis, design pattern analysis, use cases, sequence diagrams, and proposals for future. This was different from how we did it in the first report. This time we started by analyzing the source code using understand, and we did a subsystem analysis, which was mainly focused on the instant messaging. Last, we did a reflection analysis for the discrepancies between the concrete architecture and the conceptual architecture. As discussed earlier, the core of Yummy's architecture is not the controller, but the model, and the model contains four subsystems: IM, media, SIP, and security. This is the dependency graph of the model. A couple of things to note. First, we add the D-ring subsystem to the controller layer. Second, we merge the audio and video modules into the media subsystem. By analyzing the Yummy source code, we found a different dependency relationship from our recovery of the conceptual architecture. Two unexpected dependencies are between the view and the model, and between the controller and the network. This was because the clients in the view layer and the security in the model layer are dependent, and the communication data between users need to pass through the P2P network in the network layer, so the controller and network are also dependent.
There are three main functions of instant messaging: message synchronization, message storage, and message retrieval. Message synchronization is the complete and fast delivery of a message from the sender to the receiver. The most important measurement indicators are real time and completeness. Message storage is the persistent storage of messages, and the receiving end stores the message locally, which is convenient for users to view and retrieve. Messages are generally text, so supporting full text retrieval is also one of the necessary capabilities. The message retrieval function in Yami supports full text retrieval and time-based retrieval. The core components of instant messages are message queue, message processor, message storage and index library, and message synchronization library. The code showing on the left screen uses the factory mode of the design pattern. This graph illustrates the process of sending a text message from client A to client B. When client A sends the message, his screen will show the message and controller will handle the message to the model. It will request sending message to client B. The D-bus will receive the request and add it to the queue. The handler synchronizes and stores the message. When the process is successful, model will display the message to client B's interface. Also display message send signal to client A's interface. When client A wants to make a call, he needs to send requests to D-bus to check if the contact is busy through D-bus. Then the client needs to wait for response. At the same time, the system negotiates and encrypts the socket for security. If client B accepts the call, the D-bus will create 4 sockets for media and audio. Then both A and B interface will display the media and have audios. Here are the sequence diagrams for sending the message and receiving the message by instant messaging. These are the interface of instant message subsystem. Despite Yami is a relatively secure app for communication, there are still potential features or changes that could be implemented in the future. Imagine you are watching a video on your phone and your friend sends you a message on Messenger. You don't want to pause that video, but you want to chat with a friend, so you open your laptop and sign in your Messenger account. Then you found that the message he just sent me have already synchronized on my laptop. That's amazing. And that is the feature of synchronizing message across different devices. This is our enhancement goal. Now let's talk about the pros and cons. It is more convenient to view message history on different devices. For example, you use your phone every time to send and view messages, but now your phone is out of battery and you have to view an important message. Then cross-device synchronization can help you a lot. However, it requires network and cloud to save the message and need time to load from the database. This is what current architecture looks like. And now we added synchronization library in the model module and cloud database in network module. Now let's take a look at the sequence diagram for message synchronization. Unlike the previous sending message sequence diagram, we added cloud database to upload message and synchronize data to library, which is called synchronization library. The use case for message synchronization is when device 1 log in, user send message to another user. The message is uploaded to the cloud. Then, when other device log in to the same account, the device will automatically download the message from the cloud database. What we have done in this project is we derived the conceptual architecture by Yami documentation. We recovered concrete architecture by analyzing the source code of Yami, and we enhanced the message synchronization feature of Yami. In the process of doing the whole project, our team has learned a lot, mainly including the following aspects. It is necessary to review conceptual architecture before getting started to recovering concrete architecture. We need to divide our group work into several parts and allocate to each group members. Also, we need to schedule our time spending on every single procedure of the project research. Thank you for watching our group project.